We'll talk today about how to get started on human-machine collaboration, and start maybe with the very first question, which is, why would you want to do human-machine collaboration in the first place? Well, there are certain situations that are actually really good to apply AI because you have, for example, systems that are too complex for human understanding. You can think, in the medical field, human body, for example. You can think in the world of technology in general, or the latest airplane. These are all technology that are beyond human understanding, just on the fly like this, and you need to vulgarize for a human. So great place to use AI. But at the same time, those systems are just too critical to be entrusted to an AI, probably narrow AIs as we have today, right? So we're not yet to a world where we could trust, for example, a surgeon to be entirely driven by an AI. We're not yet to a world where we could trust 911 operators, for example, to be entirely driven by AI and making life and death decision, right? And so in the specific situation, your ideal solution is to actually have a collaboration between a human and a machine. The challenge is, as you most well know, is most of today's machine learning techniques and the training techniques don't really have any human involvement, right? You think of supervised learning, which is the most common one. It's essentially about identifying pattern in large amount of data. I mean, human intervention is very much limited to labeling. It's very small, so not really something that you can really train collaboration on. And if you look at a more recent technique like reinforcement learning, which is really interesting in many ways, it's still about an agent that is learning at superhuman speed, right? The way you'll train an RL agent to play chess is because it will be doing thousands of years of equivalent human playing chess in a matter of weeks or months, right? So unless you train with Superman or Flash, which I still believe don't exist, you cannot really train on human-machine collaboration, right? And so when you think about it, you don't really have a condition to establish collaboration type of training. And we believe really that the solution is in building what we call common experiences, where you can have both an AI agent that learns directly from interactions having with a human, but at the same time you can have also the human that learns from interaction with AI, which creates that sort of virtuous circle of learning and training between both. Now I'll let François talk about how do we do that.
Yeah, so that last slide that Dorian shared, like many of you in the audience will probably have clicked immediately that a continuous loop of learning like this, it sounds a lot like reinforcement training, right? So we could just throw a human in the loop of reinforcement training and we'd have sort of the basis of where we want to go. And frankly, this is not exactly anything new, right? People have been experimenting with injecting humans within the reinforcement learning process for quite a while now. And it's pretty easy to show results where you'll have an AI agent that will learn to accomplish its task in a way fewer episode than it would have had when a human is involved in sort of assisting it within the training process, then you would have abstained with a pure reinforcement training algorithm. Obviously, this comes at the cost of being able to run a lot fewer episodes, but in the case where you're sort of training the AI to learn to work with the human, it's not really like you have an alternative at all. But we want to push this a lot further. It's not just a question of taking a reinforcement training algorithm and sort of injecting a human in the process willy-nilly, or as a supervisor, or as sort of a means to guide the training process. We want to push this towards what we're basically a multi-agent reinforcement learning problem, where we're going to be treating the human-in-the-loop reinforcement learning as a very special case of multi-agent RL, right? And that's well and good, and we'll have the idea that our agent that we're training, or potentially agents that we're trying to train, is going to be operating in the environment alongside the human who'll sort of pretend to be another agent within the environment. But as we do this, we're fairly going to quickly run into quite a few problems. Chief amongst those is going to be data scarcity. I've sort of mentioned it a little earlier. When you are doing human-in-the-loop reinforcement training, as opposed to doing traditional reinforcement training, where you can run like thousands and thousands and thousands of episodes at a time, you are really sort of limited by the amount of humans you have at your disposal and the reaction time of those humans. So what you will want to do is you will want to gather a lot of data. You will want to be really, really liberal with the way you actually collect the data and retain the data. Because at the end of the day, again, unlike a traditional reinforcement learning environment where you might sort of eventually come back to the point where you were and try a different alternative, your human will never be in the same state as he was before. So you need to take that into consideration. There is no reproducibility whatsoever involved here. So it's really important to collect the data as much as possible. And at the same time, you need to leverage your humans as much as possible. Asking a human to just contribute to the reward function is easy. And a lot of people who are experimenting with human-in-the-loop reinforcement learning will start there, right? So we're going to say, we're just going to apply a bias to the reward function that is going to come straight from your human. But you can get so much more from your human. You can get not only sort of an opinion as to whether the agent is being helpful or not, but you can also get information about why that agent is being helpful or unhelpful, potentially have alternatives for what the agent should have been doing in a given circumstance. So you need to sort of try and frame the experience as much as possible to try and extract as much value out of your human as possible. And really, it's really important to just not limit yourself to a single training method. At the end of the day, we're trying to train a policy. The reinforcement learning is a means to that end, and it does not have to be the only sort of contributing factor to the evolving of the policy over time. You can combine reinforcement learning algorithms, and you can combine reinforcement learning algorithms with supervised algorithms as well. We're going to see a few more examples of what later. Second other thing is you'll quickly run into a situation where there's a lot of moving pieces. You got to deal with environments, you got to deal with agents, you got to deal with user interfaces, you got to deal with synchronizing all of this. You will almost certainly going to be doing this over a network almost immediately. So there's a lot of things to juggle, and if you don't have sort of all your ducks in a row, it's really easy to get into the weeds. And it's really important to sort of be very mindful of this off the get-go. And finally, and I'm just going to touch on this, is it's really important to think about the way you're going to be presenting the training process to the humans. Humans are fickle. They don't like to be bored. They don't like to be annoyed. They don't like to be distracted. And it's really, really easy to frame your experience in a way where you will quickly learn which button makes a window go away faster than anything. And this is a whole other thing. We just don't have time to get into this. But like, if you come out of this with anything, it's do not underestimate how tight your UX has to be in those types of circumstances. So the way we're tackling all of these things and try to get a human-in-the-loop, multi-agent reinforcement training environment in place for our experiments is coming from two separate sort of techniques we're applying. The first one is what we call the actor abstraction. And I sort of hinted to that earlier. The idea is that your environment is going to be populated with just a population of actors. And actors can be agents, actors can be humans, actors can be scripts, actors can be fully random. It does not matter. The important thing is that they are interchangeable. And once you have those interchangeable actors, it opens up really a very wide expressive space in which you can actually create various different training topologies. And also, which I forgot to mention, I apologize, the idea is that the selection of which entity will be filling the role of which actor is something that needs to be entirely dynamic, and that needs to be actually configurable on a per episode basis. So this is a very easy way you can get over the data scarcity problem in certain cases. Why? Like the fact that you're going to be injecting humans in the loop into your training environment does not mean that it has to be the only training you do. You can be running pure RL where the role of the human is being taken by either a script or by an agent, or potentially an agent that has learned through imitation learning to approximate as best as possible how humans have been contributing to the process, so that you can supplement your training process with other means. The other big thing you can do with this is what we're calling agent bootstrapping, where you'll say, well, I'm going to start my training process, but instead of just putting a completely untrained agent in there and have him interact with the human, which is going to be very frustrating because you don't want to be interacting with sort of a co-pilot program that tells you literally random stuff. I'm going to throw in a heuristic agent that is coded using traditional algorithms, but has maybe a bit of stochasticity thrown in, so it's a little exploratory in nature. And then the actual experiences that the human will have had interacting with that human can be, through our very liberal data gathering policy, use sort of a starting point from which we can do supervised learning on our actually trained policy before swapping it into a reinforcement training regimen through a hot swap in between episodes. And this is just the tip of the iceberg. Once you've got sort of that playground of having different permutations of actors and agents that you can bring in, that opens up a lot of different possibilities. The other big piece of the puzzle, and this is a bit of a tough pill to swallow, is just go straight for a microservice architecture from day one. Prototyping in a Jupyter notebook to then transfer into something that's a lot more like a production environment is basically going to lead you nowhere. You have to go straight to an environment where your environments and agents are running on a distributed manner, and that you have your humans that are going to connect in. So jump over the prototyping phase straight into something that looks a lot like more production. And these two things are sort of what we're applying a lot at AIR. And that's sort of the mental framework against which we are approaching all of the use cases we are tackling. Now, obviously, we don't want to have to build everything, all of these things, every single time from scratch. So what we've done, and this is we've actually built a library that we're calling Cogment that basically handles most of that off the get-go. So the idea is that you sit down at your desk and express, okay, well, in this environment, there's going to be these types of actors. For each of these types of actors, that's what the observation space and action space is going to be. And this is how I'm going to decide which actors are in the process. And then the Cogment library will sort of set up your microservice architecture for you, and will create a bunch of little bootstrapping code that will allow us to sort of operate in a way that feels a lot like working with OpenAI Gym, where I can just jump in and implement my agent as a function of observations in and actions out, and I can implement my environment as just something that has dynamics that evolves over time, consuming actions and generating observations. But through the whole process, the Cogment library will sort of handle all of the machinery of distributing that over a microservice architecture. And the fun thing is, we're actually doing this as an open source project. We really believe that this is the way to tackle things. And frankly, we believe that as more types of those environments are going to get built and more people are going to play around with those concepts, this is going to be, we believe, is the way things are going to be. So the whole core of it is actually entirely a free open source software called Cogment. It has all of these nice things. Unfortunately, I don't really have time to go over the details, but basically it solves most of the problems that we have expressed. You can check it out at cogment.ai, play around with it. It's kind of rough around the edges right now because we're still building the thing, but we're in the process of ramping up to a proper, clean 1.0 release by the end of the year. But if you want to come in, play around with it, or contribute, you're more than welcome to do it. And yeah, that's the presentation.